This example, it is required to find out magnetic field at O due to this semicircular current element, and this is straight current element, and another semicircular element and another straight element. There are 4 elements, and what all the 4 elements creating a magnetic field at this point, that we are interested to find out. Let us name it. This is A, this portion is AB, this portion is BD, this portion is CD. This is semicircular with radius R1, this is semicircle with radius R2. And let us find out for the portion 1. This is, we can call it as a, this is portion 1, this is portion 2, this is portion 3, this is portion 4. See, the Biot-Savart law is equal to mu naught into I dl sine of theta divided by r square, or in vector form dv vector is equal to mu naught by 4 pi into I into dl vector into r vector divided by r cube. What is theta? Theta is the angle between dl vector and r vector. This theta, because it is vector form. If you are vector form, you are ideal sin theta into unit vector along this one. So what is theta? Theta is equal to, see, for this portion we are talking about portion AC. This is A and this is C. So current is flowing this way. So dl vector is in this direction, and this is the point O here, point O, and this is R1 vector. So R1 vector is in this direction. So dl vector is in this direction, R vector is, R1 vector is in this direction. So theta, angle between dl and r vector, is equal to 180, and sine of 180, theta is equal to 180, sine of 180 is equal to, and sine of 180 is equal to 0. Therefore, what about the magnetic field? For first problem, first portion, magnetic field is equal to 0. Why dV is equal to 0? It means what? A small portion is producing a 0 magnetic field at O. It means all, when we add all the small element, it will 0 plus 0 plus 0 is the total magnetic field produced by this line segment AC at O. Now second one is, this is the case for BD. Let us say BD also same. Already we told the magnetic field on the line of the straight wire is 0. We apply the same rule, straight away we can come to the conclusion. See here, this is BD, and current is flowing how? Current is flowing in this direction. Current is flowing in this direction. It means dl vector is in this direction. What about R? R is from here. This is R from O. This is R vector. Sorry, R1 vector. So R1 vector also in this direction, theta is equal to 0. It means sine of 0 is equal to 0. It means entire portion is equal to 0, because sine of theta is equal to sine of 0 degree, which is equal to 0. It means this portion have become 0. It means entire portion will become 0. Therefore, dB is equal to 0. That implies B is equal to summation of all dB, which is equal to 0 plus 0, and so on, is equal to 0. So for the portion number, this is for the portion number 3. This we have written for portion number 3. This is for portion number 3, or we can call it as B3, and portion number 4, that is B4, is equal to 0. Now semicircular part already we have derived for the semicircular part. What it says for semicircular part, the result is Result is magnetic field is equal to integral of dB, which is equal to 4 pi mu naught I divided by 2 into the distance into theta angle subtended divided by 2 pi. Why? Because this already we have explained it. Now here, what is R? Here for the portion 1. Portion 1. R is equal to R1 because for the portion R, and angle subtended is equal to semicircle. And semicircle means pi. Pi, it means we can say B1. We have to write B1. What is B1 is equal to, from substituting mu naught into I and divided by 2 into R1 into theta is pi. This is equal to 2 pi, cancelling this is equal to mu naught I divided by 4 R1. It means for the portion 1, it is B1 is equal to mu naught I divided by 4 R1. What is the direction? Because the current is flowing this way. When we circle it with the right hand, it means it is above the inside this one. It is inside. It means here is inside. Because this is going like this and we hold it, it is inward. So it is, the magnetic field is inward. This also we have already derived. That is, since dB is equal to mu naught by 4 pi into I into dl into sin theta by r square. Here the r is equal to r1. Okay, we write it as r square. Since sin, what is the theta here? Theta for this one. See, this is the semicircular portion. This is dl and this is O. This is r1 and the angle is 90 degree. So sin 90 is equal to 1, or we can write mu naught by 4 pi into I into r square into integral of b is equal to integration of dB. So we will integrate this portion is equal to mu naught I divided by 4, substituting r square, this is r square, since r here is equal to r1 into dl. For semicircular region, it is pi r1 into pi into r1. So this mu naught by 4 pi, this get cancelled, this get cancelled, is equal to mu naught I by 4 r1. Mu naught I by 4 r1. Same way we can calculate for this portion. This is also semicircular. This is semicircular portion with the radius r2. So this is portion number 2. For portion number 2, same procedure follows. The same procedure follows means what? B2 is equal to mu naught I divided by 2 into the radius r2 into angle subtended divided by 2 pi is equal to mu naught I divided by 2 r2 into theta. What is angle subtended by this semicircle with the center is pi 180 degree, because it is coming like this 180 degrees. That is pi divided by 2 pi is equal to mu naught I divided by 4 r2. It means for portion number, this is portion number 2. 4 r1 is portion number B2. B2 is equal to, with vector we will write mu naught I by 4 into r2. Direction for this portion, current is coming this way, so we will put our right hand this way and we move it. This is going inside. This is outside, but we are interested to find out O means inside. So this is inside. So net magnetic field is a vector. So net magnetic field in vector form is vector addition of all the magnetic field, that is equal to B net in vector form is equal to B1 vector plus B2 vector plus B3 vector plus B4 vector. So B1, this portion is equal to mu naught I divided by 4R1 and its direction is inside. This is magnitude and this is direction inward, and B2 is equal to mu naught into I divided by 4 into R2, and B3 is equal to 0, B4 is equal to 0 plus 0. So B net in vector form is equal to, we'll take the common factor out, divided by 4 into 1 by R1 plus 1 by R2. Since both are in the same direction, this is also in the same direction, the direction is inward. So this portion does not produce any magnetic field at this point. This also does not produce any magnetic field. These produce a magnetic field, and the magnetic field is at this point is inward. This also produces a magnetic field inward, and the direction of magnetic field depends upon the direction of current. If the current is this way, if the current is flowing this way, then we'll put like this. It means outside is outward, inside is, in that case it will become like this. Of course, this problem, this is not valid. So this is the net magnetic field.